Ma'am. Mm-hmm. Mm-hmm. Yep. Okay, so do you guys remember, first of all, do you remember doing the project out in the hallway? Yeah, well, obviously you don't. You weren't here last year. Oh, okay. We had fun. It was a fun project, just so you know. So I'll try to make this as fun as that. It will be impossible, but I'll try. Okay? What is a system of linear equations, first of all? Do you remember? There's at least two, right? If we have two variables, how many equations do we need to solve the system? Two. If I have 5 variables, how many equations do I need to solve the system? 5, right? However many variables I have, that's how many equations I need to be able to solve the system. Okay? If you'll remember, obviously everyone will but Carson and Jacob, because they weren't here, but this is what I did my senior project on in college, solving systems of equations. Okay? I did Hardin-Simmons versus Howard Payne, baseball. We knew all the statistics. We had every batter's batting average for every specific pitcher that they pitched. Okay? And so we said, if you know who the batter is, who should pitch? Like if you know the lineup, who should pitch? But also you can look at it the other way around. If you know who's pitching, who should you bat against that pitcher? Right? Batting average wise, stuff like that. So Dr. Potter, who works at Hardin-Simmons, he was my senior project advisor. He and I worked on that all semester. We had 9 variables. So how many equations did I have? 9. Okay? So if you guys are going to complain about doing 2 by 2, I'm just going to give you tissues and just cry with you. Actually, I'll probably just sit by you while you cry because it's not that hard. You got this. Okay, but this system of equations is something I really, really like because of the applications that you can use it in. So many different applications that you can use it in. Okay, we'll talk about some of them today. You'll have some word problems about some more on your homework. All right. So first objective that we have is deciding whether it's a solution of the system. Okay. Today specifically, we're only talking about linear systems. All right. So I have this linear equation, this tells me right here, this little pretty brace thing over here tells me that's a system. These two are working together. And I'm saying, is this the solution? Well, before I can even go on for that, I really feel like we need to talk about what is a solution to a system of equations. What is a solution? To where they cross, right? So in this particular system, if I've got my pink X and Y axis and I've got a green line and a purple line, where is the solution? Right there. That's the solution. That's one solution, right? Does that make sense? What about here? She said it's where they cross. Except they don't. So I must have been wrong in what I said, right? There's just no solution here. If they don't cross, there can be no solution. Okay, I don't know if you can tell this, but here's the green line, and then here is the purple line. How many solutions does this system have? We're going to say it's infinitely many. Okay, infinitely many solutions. So not only are we going to decide like all these objectives, what they talked about, we're also going to talk about what it looks like when we have one solution or no solutions or infinitely many solutions. Okay? You okay with that? So back to this problem right here. How do I decide if this point is a solution? I can just plug it in, right? Okay? So if this is x and this is y, I plug it in. 4 plus 2 times negative 1 equals 2. So 4 minus 2 equals 2. So that means that's a solution, right? Can a point lie on this line and not on this line? Very easily, right? Even just looking at our graph, can a point lie on the purple line that doesn't lie on the green line? Yeah, in fact, all of the points on the green line lie on the green line and not on the purple line except for that one, doesn't it? Okay, so we also not just have to plug it into one, I have to plug it into both. Okay, so x is 4, y is negative 2, so 4 plus, sorry, I wrote the wrong number. That's a 1. 4 plus 2 equals 6. So is this a solution to this system? Yes. What about this point? Is this point a solution to this system? Okay, Delaney is telling me no, and we haven't even done any work. Why are you telling me that, Delaney? If it has one solution, is it going to have more than one solution? Well, it could. It could be infinitely many, right? But we can tell by looking at this, because of the other stuff we've already talked about, that these are not parallel lines, and they're not lines that are right on top of each other, right? So we already know that it's not, but let's check, okay? Let's just practice our arithmetic, if nothing else. So negative 4 plus 2 times 2 times 3 equals 2. So negative 4 plus 6 equals 2. That works. So are we doing something wrong? Oh, we had to try the other line. Okay. Negative 4 minus 2 times 3 equals 6. So negative 4 minus 6 equals 6. No. So is this a solution to that system? No. It's not. Okay? Any questions about deciding whether an ordered pair is a solution of a linear system? Okay. The next objective talks about substitution. Do you remember how to solve a system by substitution? Well, it does imply at some point that you're going to substitute something in for something else, right? So what we need to do is choose a variable. We called it a runt variable because it's the littlest, smallest variable that we could choose. So here, what would be our variable you want to solve for? The bottom x, right? So if I solve for that bottom x, how do I get that bottom x alone? Add 2y, very good. So x equals 2y minus 3. Where? Okay, so I use the second equation to solve for x, so I don't want to put it back into the second equation. That would be silly. Okay, if I'd use the second equation, I want to plug that into the first equation right here for x. So I'm just going to start rewriting the equation, 5, but I'm not going to write x. I'm going to write what I know x equals. 2y minus 3, then minus 4y, and then equals 9. Everybody okay with that? Then this is just a basic Algebra 1 problem now. Distribute, 10y minus 15 minus 4y equals 9. Combine your like terms. 10y minus 4y is 6y minus 15 equals 9. Add 15 to both sides. 6y equals. You can do it. You can. Okay, 24. Divide both sides by 6. Y equals 4. So that's my answer, right? You want to check it? How do you want to check it? Wait, is that my answer? Where's my answer? The point where they cross, right? Is the point where they cross a y value? It's an x and a y. So I tricked you. Don't let me trick you. What am I going to do with this y? This one right here? I mean, you can. Yeah, I would go right here, right? I already have x solved for, and I know y, so I can go x equals 2 times 4 minus 3. 2 times 4 is? 8 minus 3 is? Is that my answer yet? No? Oh, yeah. How do you want to write it? Does it matter what order we write it in? Oh, yes. Absolutely it matters. Okay? 5, 4 is my solution. Now let's check. Right? Now let's check. Again, do we have to write anything down on our papers to prove that we are checking? No, we just need to do it, right? 5 times 5. Okay, 4 times 4. So 25 minus 16. Okay, that works for the first problem. 5 minus 8. Does it work for the second problem? Then I am absolutely sure that that is my answer. Okay? Any questions about that? Yes, ma'am. This one? X? No. I mean, we could call it like Franklin or something if you want. That's fair. Yeah, no, I appreciate you asking. I really don't think so. We just solved for a variable, so it could be the equation that we have solved for a variable. Yeah, but I don't think there's a name. I like Franklin. Clifford Franklin is one of my favorite characters in any movie, just for the record. The Replacements. He's a character. It's not like an actor's name. The character's name is Clifford Franklin. He's a receiver. Super, super fast. He cannot catch a darn thing. No. It's a cute movie, for the record. I keep it on my phone so I can watch it whenever I want. Now, we solved this system of equations by substitution, right? Our next objective says solve linear systems by addition. Guys, I never taught you how to do linear systems by addition. I did teach you how to do linear systems by elimination. And that's what this book calls addition. So you do know how to do it. We just haven't called it that before. Some of the stuff that we do and this book does from Algebra 2 to College Algebra, it's the same thing. It just has different names, right? Because we had standard form and general form of a quadratic, but we called it standard form and vertex form. Remember stuff like that? Okay, so just a couple different names. Here they're calling it solving linear systems by addition. We called it elimination. So let's solve this system by elimination. Elimination, we're trying to eliminate a variable, right? Which variable would you like to try to eliminate? You want to do y's? Sir?
It doesn't matter, does it?
No, it does not. No, it does not. It doesn't matter at all. Typically, like in this particular problem, I might choose the y's. And the reason I might choose the y's is because these are already opposite signs. So when I go to add them together, which is why this book calls it addition, okay, when I go to add these two equations together, I already have opposite signs here. I don't have to deal with multiplying by a negative. However, I'll be multiplying it by a 4, okay? Now somebody else might choose to eliminate the x's because then I'm really only having to multiply by a 3. Now it's a negative 3, but 3 is less than 4, and sometimes people like the smallest ones. Do you see what I'm saying? Okay, so really it's your choice whether you want to eliminate the x's or the y's. So what do you choose? You want to choose y's? Okay, so we'll eliminate the y's. If I'm going to eliminate the y's, remember the rules about it. They have to be the same number, opposite signs. Okay, this one's a 2 and this one's an 8. What number do I want them both to be? Probably 8, right? Well, this one's already an 8. It's a negative. That's good because this one's a positive. What do I have to do to this one to make it become an 8? Because I can't just go poof, it's an 8, right? If I multiply it by 4, what else do I have to do? The whole equation by 4. Otherwise, I've changed the value of the equation, right? The system, and I will never be able to get the right answer. So if I multiply the top equation by 4, I get 12x plus 8y equals okay, let's work on our numeracy for a second. What is 4 times 50? 200. That's easy, right? I'm only asking for 48 though, so I need 2 groups of 4 less than that. 192. What did I say? I meant to say 2 groups of 4, so 8 less. I don't know what I said. I'm sorry. Yeah, that's absolutely another way that you could do it. What's 4 times 40? 160. And what's 4 times 8? So what's 160 and 32? 192. Okay? Always more than one way to get to an answer. Good job. Okay? So this equals 192. And then what do I do with the second equation? Just rewrite it, right? 9x minus 8y equals negative 24. Do you remember what you do with these two equations? Combine them. Yeah, add them together. What is 12x and 9x? 21x. What's 8y and negative 8y? 0. And what's 192 and negative 24? Are you just making up stuff? I'm just teasing.
That's it. I'm so good at math.
I know. 168. Hey, it's 168. And now? Okay. So what's x equal? 8. It's definitely 8. You could check your math by saying 8 times 21. Is that 168? You guys are freaking me out so much today. The other thing that you could do is get your calculator if you're freaking out about it. My goodness. It's broken. I did tell you to get another one. I'm not mad at you. You're fine. Okay, is this the answer?
No, it's not. Oh, I'm the smart one here.
Oh my gosh.
It is not.
Okay, it's part of the answer though, right? Okay, so how do I find the rest of it? Where would you like to plug it in? Which one do you think would be easier, top or bottom? Probably top, right? The numbers are smaller. Okay, so we have 3 times 8 plus 2y equals 48. So 3 times 8? Okay, plus 2y equals 48. Whoops. Yes, ma'am. And then divide by 2? Y equals? 12. So what's the answer? 8, 12. I mean, 12 has a 2 in it. That's good. That's good. Yeah, just a bunch of 2s. Okay. Is that the right answer? Could you know for sure? Okay. So 3 times 8 is 24. Plus 2 times 12 is 24. Is that 48? Okay, that one works. 9 times 8 is 72. 8 times 12. 96. Oh my gosh. Okay. Is that equal negative 24? Yes. Okay, so this we know for sure is the right answer. Got it? Okay. So it's not on our objectives, but something I want to talk about real quick and just at the beginning of this next problem is if you're given a problem, is there a best way to choose? Some of you like elimination or addition more than you like substitution. Some of you like substitution better. But sometimes because of the way the problem's set up, is there a better way to choose? Okay? So look at this problem. Is there a better way to choose to solve this problem? What way? Substitution. Why would we choose substitution to solve this? Yeah, y is already solved for. If I want to do elimination or addition, I'd have to get it back in a standard form. The x, the y, the equals, and then the constant, right? Okay? But I already have y solved for, so why can't I just take this right here and plug it in right there? Okay? 15x minus 5 times 3x minus 2 equals 10. So 15x distribute, minus 15x plus 10 equals 10. Well, let's think about this for a second. 15x minus 15x is what? 0. 10 equals 10. So we have two choices, right? Looking back at our graphs that we looked at a second ago, I have two choices. I know there's not a solution. I either have no solution or infinitely many solutions. Well, I say that I know there's not one solution. Okay? I have either no solution or infinitely many solutions. Here's the way to tell. Does 10 equal 10? Will 10 always equal 10? On every universe I've lived on, 10 equals 10. There might be a universe where it doesn't. I don't know where it is. I don't want to go there. Okay? Guys, that means any values I put in for x and y, any values that I put in for x and y, it's still going to simplify down to 10 equals 10. 10 does equal 10, so infinitely many. All of the solutions work. Okay? Any questions about that? What about this one? Is there an easier way for this one? Probably not substitution. I don't have a variable solved for, right? There's also not a runt variable. There's not a variable that's all by itself. Everybody okay with that? So which variable would you like to eliminate here? Well, which variable would you like to eliminate? Let's do that. Yeah. X, okay? If we're eliminating x, what do I want both variables to become? How about, we could do 24 if you want. There is a smaller one, right? So 12. So what are we going to multiply the top equation by to make it become 12? 3. And the bottom one? 2. Now, obviously, one of those is going to have to be negative so that I have opposite numbers, right? Which one do you want to multiply by negative? Negative 2? Okay, so if I multiply the whole top equation by 3, I get 12x plus, equals 36. Good job. Now what? Which is? Negative what? 24? That's all right. It's okay. Now, combine them. What do you get? Does 0 equal 12? I only have 3 choices. If the equation that I simplify it down to is true, I have infinitely many solutions like the problem I just did. 10 equals 10. If the equation I simplify it down to is not true, I have no solution. No values of x and y that I put in here will ever make this work. Now, because of the fact that they both equaled 12, could I set them equal to each other? Let's do that way and just see what happens. Okay? 4x plus 6y equals 6x plus 9y. So what do I do? Subtract 4x and subtract 9y. So then what? Negative 3y equals 2x. What does that tell me, though? It doesn't make any sense. I don't have any constants to help compare this to me to actually solve for either one. And that's why I didn't do it first. Is that fair? Okay. You're welcome. Any questions about this? Okay, so let's look back at our objectives really quick. Okay? Determine whether an ordered pair is a solution of the system. Can you do that? How do you do it? Plug it into the system, right? Solve linear equations by substitution. Solve linear equations by addition. We called it elimination. Can you do it? Identify systems that do not have exactly one ordered pair solution. What are my 3 choices? Okay, these are my 3 choices. These are the 2 that they're talking about to know that when they have do not have exactly one ordered pair solution. It's either no or all of them. Okay? And now you know what it looks like when you solve the equation. If it's a true statement, then it's infinitely many. If it's a not true statement, it's no solution. Got it? Problem solving using systems of linear equations. I already told you, right? I already told you what I dealt with my senior project, right? Okay? Can you personally see any applications of this? Systems of equations. Sports, probably. What about if you're going to the grocery store and you have a set amount of money, but you have to buy some apples and oranges? but you got to figure out how many apples you can buy and how many oranges you can buy, but you know the price of each one of them. Would that help? Mm-hmm. Mm-hmm. That was one of the problems. You had a piggy bank and you knew there were 100 coins in the piggy bank, and obviously you know how much a nickel is worth and how much a dime is worth, and you know how much total money is in the piggy bank. You could figure out how many nickels and how many dimes are in the piggy bank. That was exactly one of the questions on the project. This. Yeah. It's just not time for us to talk about that yet. But yes, remember, you can solve these with the matrix. Okay? Say it one more time. Oh yeah, I would not be surprised at all if this showed up on ACT or SAT. In both of the sample problems that we're working through in regular algebra 2, we've seen several systems of linear equations on there. Oh, Parker. We should talk. Okay. All right, do you have any questions on systems of equations? Do you feel like we covered all the objectives of today? Okay. Now, I know we didn't do any examples of problem solving, but we did talk about several examples. And I guess the main problem that some people have is taking a word problem and getting the problems out of that. Okay. I know some of you are quite good at it because I had you last year and you could do it last year. So if you don't remember, what should you do? Oh my gosh, you should ask me. I love to do this stuff. Okay? So just ask for help. I want you to sit and work on this today. If you need a Chromebook, I can go get you a Chromebook. Okay? But I want you to sit and work on this today. Start with your problems so that I can answer questions while I'm in here when you're going through them. Okay? Any questions?
But you're saying you're our teacher that will help us?
I am. Yes, I am your teacher, and I will help you with your math problems. No, for real. Yeah. Okay. Peace.